I am Bendjeroudib Chafia, a PhD student at the University of Tbilisi and a member of Applied and Theoretical Physics Laboratory. I am very happy to participate in this conference. This work is titled Structural and Magnetic Properties of Iron Thin Films Grown on Monocrystalline Substrate Magnesium Oxide 001. Work plan, abstract, structural properties results, magnetic properties results, and conclusion. In this work, the iron-silver thin films were prepared by molecular beam epitaxy deposition on the monocrystalline magnesium oxide 001 support. To study the structural properties such as grain size, the magnetic layer has a fixed thickness of 300 angstrom, while the insulating layer of silver varies from 50 to 150 angstrom with a difference of 50 angstrom. The structural properties of the sample were examined using the X-ray diffraction method. The measurement results indicate that the grain size and the coercive field increases monotonously with the increases of the roughness, and this affects the structural properties of the thin film. Lattice parameter, the X-ray diffraction allow used to calculate the lattice parameter of all the crystal lattice from this relation. And their values are represent the difference thickness of the before layer in table 1. This table is noted that the values of the lattice parameter of all the crystalline network and in all the samples are varied with those of the theoretical values, which answers the effect of the growth on the structural properties of the layer, which confirms the presence of stress during the growth. Thus, it's obvious that the lattice parameters of the silver before layer are higher than that of the theoretical values, indicating that this layer in a state of compressive stress. The lattice is dilated explained by the negative between this layer and the substrate. Moreover, it's clearly seen that the constant of the lattice parameter of the magnetic layer of iron and lower than those of the theoretical values show that the iron layer is in state of contraction. Grain size determination. The values of the grain size values as a function of the thickness of the silver before layer and reported in figure 1. In the later, the crystal size is smaller of the case of the minimum order of roughness, which is observed first in the case of the direct growth of the magnetic layer of iron of the substrate, or other word side in the case of which and illustrate in the good quality of surface and interfaces and secondly, in the case of where the quality of surface and surfaces has been improved in the continuity of the before layer, which decreases the values of lattice mismatches between the iron and the substrate and leads to growth layer by layer. On the other hand, the maximum value of the grain size was found in the case of thickness and corresponding the maximum values of lattice disagreement between the layers, so it results that the size of the crystallite increases is in quasi-monotonous, while with the increases of the roughness. Determination of the formation values. The strain values were calculated using the Stokes-Wilson relationship. Their variation as a function of the grain size of the iron layer is illustrated in figure 2. Where we observe the microstress increases in a linear way with the increases in the crystallite size of the iron. This is due to the lattice mismatches between the layer, which coincides with the thickness of the silver before layer. Indeed, the grain size directly proportional to the late mismatches, which link to the roughness. When the grain size increases to the determinant of that of silver, the interdiffusion between the layer increases and consequently the deformation increases, and vice versa. On the other hand, the grain size has a small values in the case of the lead has a small deformation values, respectively, means the good condension of this greases sample has the smallest order of late mismatches between the layers. The maximum strain value of found in the sample whose of roughness is maximum. This may lead due to the expansion of the crystalline layers of the films. Coercivity measurement. The variation of the values of the coercive field as function of the grain size when the magnetic field is applied alone to the direction of the easy axis presented in figure 3. In this diagram, it's seen that the coercivity is zero for the sample without the before layer, or the roughness order will be minimal and the grain size smaller. However, the loop was nearly receivable ended in this sample equal to zero. This suggests that the magnetization reversible procedure was dominated by the rotation of the magnetization and that the contribution to magnetization reversal by movement of the wall of domain was negligible. It is also observed in the grain size increases. The quality of surface and interface will be affected by the increases in the value of late mismatches between the layer or the deformation translate into the presence of roughness in the surface and the interfaces of the layer, which lead to the increases in the values of the coercive file to a maximum value corresponding to the small sample of which and the size of the grain which has been known by their poor quality. The increases coercivity that suggests that the magnetization reversal procedure was associated with magnetization rotation and the domain wall motion at the same time. So we deduced that the magnetic results are indeed equivalent to the structural results found by X-ray diffraction. Finally, by conclusion, from the structural results obtained by X-ray diffraction, we can say that the variation in the thickness of the silver before layer influences that property of the iron layer. These results are attested on the one hand by the shift of the Bragg lines of all the crystalline layers which are composed of this type of samples, and on the other hand by the variation in the latest parameter values of these layers. The magnetic properties also indicates the relation with the thicknesses of the before layer which appears in the variation of the coercive field according to the variation of. Thanks for your attention.